penetrate the epidermis, or it is used.
Yes, such actually, cosmeceuticals are the combination of cosmetics and pharmaceuticals. And some cosmetics may be act as a cosmeceutical, just like a moisturizing cream is there, or any anti-inflammatory gel is there. Okay, it is a combination of cosmetic as well as pharmaceutical. So for such a types of cosmetics, you can particularly use these term cosmeceuticals. Actually, it is not more popular in India. Okay, it is not mostly useful term, but nowadays it is grown popular. Okay, cosmeceuticals, this terminology become popular. It is not included in your DNC Act, and there is no proper definition as per the rules and regulations for the cosmeceuticals. Okay, we have also seen some examples, that is the anti-dandruff shampoo. Actually, shampoo is a cosmetics, but it containing the anti-dandruff or antifungal some agents, so it can be called as a cosmeceuticals. Okay, your simple shampoo for using the rinsing the hairs, it is a come under cosmetics, but particularly when you are talking about the anti-dandruff shampoo or anti-eczema cream, okay, or particular types of you are using for the dry skin. Okay, if you are using any cosmetic for the dry skin, it may be considered as a cosmeceuticals. Okay, so this is the difference between the cosmetics and cosmeceuticals. As such, there is a no legal definition of the cosmeceuticals. Now moving towards the other second part of your topic, that is the ingredient or additives which are useful in the cosmetics. Okay, so whether my screen is visible? Yes.
Yes, sir.
Yeah, so from the slide you came to know we are going to study the surfactant for cosmetics. You know the function of surfactant, water surfactant. They are also called as a surface active agent. They are also called as the amphiphiles. Okay. So what is the reason behind they called as the amphiphile? Because they contain both type of groups, that is the polar as well as non-polar groups. And their major function is to reduce the interfacial tension between the two surfaces. And these two surfaces may be liquid-liquid surface, it may be solid-liquid, it may be solid-solid, or it may be solid gas or liquid gas. So there are so many types of interfaces are there, and they are useful to reduce the whatever the surface tension or interfacial tension which is present in between the two surfaces or two phases. Okay, so surface active agents are having the variety of uses. They may be act as emulsifying agent, they may be act as a foaming agent, anti-foaming agent, and then water in oil emulsifying agent, OWO emulsifying agent, या फिर OW emulsifying agents. So solubilizing agents are also surfactants. So depending on their particular value, that is called as the HLB value, that is the hydrophilic lipophilic balance, they shows different applications, or they are having the different uses depending on their HLB value. Okay, so surface active agents are not only useful in cosmetics, but they are also useful in pharmaceuticals. Okay, so they are most of the time in topical preparations, in suspension, emulsions, they are essentially used. So as per the definition, surfactants are compound that reduces the interfacial tension. And interfacial tension, why it is produced? Yes, anybody from you? Why interfacial tension or surface tension exist? Yes, Anjali Pawar, am I audible? Anjali, unmute yourself. Yes, Gunjan Rathod.
Yes, sir.
Yes. Am I audible?
Yes, sir. Yes, sir.
Why interfacial tension exists? What is the reason?
Uh,
Yes. Do you know?
so, viscosity property, maybe.
Viscosity is the different thing. Why interfacial tension exists?
Um, to measure tendency of liquid.
But don't search on Google and answer. First of
No,
all,
sir.
understand what I am asking. Okay, you can't give the answer whatever you are searching. You have to answer whatever I am asking. Yes, anybody?
Sir, because of the presence of two phases in a system.
Yeah, the two phases. If there is no interfacial tension, always exist in between two phases. Suppose alcohol and water. These are the two phases. Yes or no? When the two phases are completely miscible, then it means that there is no interfacial tension exist in between them. But when we are talking about the oil and water, they do not mix with each other because the interfacial tension is exist in between them. The reason is that because of their nature, their polarity. Okay, the water contains the polar group, the oil or lipid or fats contain the non-polar groups. Apart from this, when you are talking about the solid and liquid, some gases are there adsorbed on the surface of the solid. Okay, so these gases are adsorb any material on the surface of the solid that resist to mix or to get the wet. Its surface do not get wet because of the presence of these gases on the surface of the solid. So the liquid do not penetrate inside the solid. Okay, so depending on the which surface is exists, solid liquid or liquid liquid, depending on that and the nature of the solvents, the interfacial tension exists. Okay, so what the surface active agent or surfactant do? What they do? What it do? It reduces this interfacial tension. How it reduces interfacial tension? It removes the adsorbed gases if they are present and allow the surface to wet. Okay, if oil and water is exist, then surface active agent contains both the group, polar as well as non-polar group. Okay, if you can see the structure of the surfactant, the blue circle indicate the polar head, and this sky blue color of thread-like structure, that is the tail of the that surface active agent. It is the hydrocarbon tail. It is a non-polar group. Okay, tail is a non-polar and head is a polar. So when it comes at the interface of oil and water, the polar head moves or turn toward the water phase and the non-polar tail moves toward the oil phase. Okay, so they adsorb at the interface. All the surfactant adsorb at the interface between two immiscible phases, and by doing this, they mix the two phases. Okay, they connect the two phases by adsorbing at the interface. Okay, because these are soluble in both the phases. Surfactants are soluble in oil as well as in the water. And due to this amphiphilic nature, due to its amphiphilic nature, it mixes the water and oil with each other. Okay, so you can see hydrophilic part is there, which is a polar and having the high affinity toward the water. Which groups are there? Which polar groups are exist? Carboxylic group, sulfate group. These are the hydrophilic group. And hydrophobic group is the hydrocarbon chain. That is the hydrophobic group present in the surfactant. And you know that this word from the terminology, Greek terminology, that is phobos means fear. Phobia, you know that the phobia means fear. And phil means love. So water loving or water hating, this terminology also sometimes used. Water loving used for hydrophilic, and lipid loving or oil loving is used for the hydrophobic, or water hating for the hydrophobic. Okay, so this terminology can be interchangeably used most of the time, but hydrophilic means water loving and hydrophobic means oil loving. So these two terminologies should keep in mind. Okay, so this tail is the hydrophobic group, and the head is the always the hydrophilic or polar. That is the it turn toward the water surface. So depending on its HLB value, I have already told you. The surfactants are used for the different purposes, or they are having the different functions. They can be act as a detergent, they can be act as emulsifying agent, they can be act as a wetting agent, solubilizing agent, or foaming agent or cleansing agent. Okay, when you are talking about the cosmetics, okay, every cosmetic contains the surfactant, whether it is a dentifrices, whether it is a toilet soaps, or whether it is a creams or other emulsions or suspensions. Every cosmetic contains the surfactant. Okay, only its use get differ from cosmetic to cosmetic. Detergency is one of the functions. Detergency is nothing but the lowering the tension between the dirt and oil or water and your skin or hair. Okay, what they do? What does surfactant do? Surfactant entrap the dirt particle or whatever the oil or dirt particle present on your cloth. Okay, they get entrapped inside the that surfactant molecule and they get detached from the cloth. Once they get detached, once your dirt particle get detached from the cloth, it remains suspended in the that water in which your cloths are soaked. Okay, once these dirt get detached from your cloth, it do not settle again on the cloths. Okay, एक बार वो जो dirt detach कर देता है डिटर्जेंट, तो फिर से वो क्लॉथ के ऊपर स्टिक नहीं हो पाता है. Okay, so this is the detergency. Emulsification, you know that. What is the function of emulsifying agent? You know very well. Emulsifying agent reduces the interfacial tension between the oil and water, and so it is you can prepare the emulsion easily. As such, oil and water are immiscible in nature. Okay, no one can mix them together. Your conventional, or we can say your conventional emulsions are less stable. Nowadays, multiple emulsion, then micro emulsion and nano emulsions are there, in which the particle size of the dispersed phase is very small. Micro size or nano size is there, and they are looking transparent in nature. As such, your conventional emulsion, you know that it looks turbid, it looks milky. Okay, it is a non-transparent because the globule size is a very large, and so why your conventional emulsions are thermodynamically unstable. Means they remain miscible. Oil and water remain miscible for particular time period. After that time period, though in the presence of emulsifying agent, they become immiscible. Okay, that is called as the creaming or cracking of the emulsion. So they do not remain together for longer time. But when you are talking about the micro emulsion or nano emulsion, they are stable for the prolonged time. Then they are act as a wetting agent. When this wetting property is very essential because it is the first step in the solubilization. Until otherwise, the solid get wet, there is no penetration of the liquid inside the solid, and it do not get solubilized in the liquid. So wetting is the very important phenomenon. It is also required in the suspension. Okay, you know that what is the suspension? Yes, anybody from your side? Manisha, Bisen, unmute yourself. Manisha, Bisen, unmute yourself.
Yes, sir.
Yes, what is suspension or what is
Suspension
dispersion?
is a biphasic liquid dosage form.
Mhm.
For one phase is solid and another phase is liquid.
Okay. What is the requirement for the to prepare the suspension? What
Mm,
property should possess by the solid material?
Mm, ac-
First property is that solid should be insoluble. To prepare the
in
suspension, your solid should be insoluble into the that solvent. If your solid is soluble into the solvent, what happens? It becomes solution. It will not produce the suspension. Okay, but due to this insolubility property, most of the time the solid do not wet. They resist the water. Okay, and their surface, the whatever the solid particle, their surface do not get wet by the dispersion medium. Okay, so due to which what happens? Until otherwise the solid surface do not wet, it float on the surface of the water. Just if you put the talc in the water, it float on the surface of the water. Okay, so when the particle surface get wet, it gets suspend into the that dispersion medium. जब तक उसका surface wet नहीं होगा, वो disperse नहीं होगा uniformly throughout the dispersion medium. आपको soluble नहीं करना है, but उसको disperse करना है. And for dispersion, the wetting of the surface of the solid particle is essential. And when some substances are hydrophobic in nature and their surface do not wet, in that case, by adding a small quantity of surfactant into the dispersion medium will helpful to wet the surface of the solid material. Okay, so these surfactants are act as a dispersing agent. They are also called as a suspending agent. Okay, suspending agents are nothing but the surfactants. Then solubilization. If you have to solubilize something, if some slightly soluble drugs are there, they are not soluble into the water. Some ingredients are there, they are not soluble into the water. In that case, you can use the surfactant like sodium lauryl sulfate is there, which reduces the interfacial tension and improve the solubility of most of the solid in the water. Foaming agents are also there. Okay, these foaming agents are required into the shaving cream, shaving foams. Okay, that produces the stable foam for the prolonged time. The foam do not dissipate immediately, and that is the function of the this is happen foam produced because of the this surfactant only. So surfactants are having the variety of uses in the cosmetics. As I have already told you that the use of the surfactant is depend on the HLB range. HLB range, you know that it is the hydrophilic lipophilic balance. Hydrophilic lipophilic balance means how much quantity of hydrophilic groups are there and how much quantity of lipophilic groups are there. Means how many quantity of polar groups and how many quantities of non-polar groups are there in the surfactant. Depending on that, one HLB value is given to that surfactant. 0 to 3 HLB value, 4 to 6 and 7 to 9. Okay, so 0 to 9 are considered as under which category, lipophilic or hydrophilic, as anybody immediately. If the HLB value is 0 to 9, then what it indicate? Yes, Pranjal Deshmukh, unmute yourself.
Yes, sir.
HLB value is present if in between 0 to 9. What it indicate? Which type of surfactant it is?
Wait.
If the HLB value is in between 0 to 9.
0
And
to 9.
suppose if it is in
Hyd
between 9 to 18, Tell me both.
Lipophilic 9 to 18, hydrophilic 0 to 9.
0 to 9 hydrophilic.
Lipophilic.
Yeah, 0 to 9 HLB value indicate these are the lipophilic in nature.
Yes, sir.
Yeah, mute yourself.
Thank you, sir.
And when the HLB value is in between 9 to 18, it is considered as a hydrophilic surfactant. So it is clear from this value. So why 0 to 3 are act as antifoaming agent, 4 to 6 water in oil emulsifying agent. When the oil is in the external phase, WO means water is in the internal phase and oil is in the external phase. So when oil is in the external phase, you require the lipophilic surfactant. So why it needed the 4 to 6. And which surfactants are in this category? Spans are there. Spans are the lipophilic surfactant. 7 to 9 are the wetting agent. Okay. Then 8 to 18 oil in water emulsifying agent. When the water is in the external phase, you require the hydrophilic surfactant. So why 0 to 18 HLB range surfactants are required. 13 to 15 are the detergent and 10 to 18 are stabilizing agent. Most of the time what happens? You require the some particular type of HLB value. Of that HLB value surfactant is not available. ऐसे कुछ वैल्यू आपको लग सकती है फॉर्मुलेशन के लिए, बट उस HLB वैल्यू का आपको सर्फेक्टेंट अवेलेबल नहीं रहता है. इन दैट केस यू कैन मिक्स द टू सर्फेक्टेंट to produce the particular type of HLB value. That practice can be also used. By mixing 2 or 3 surfactant, different surfactant, you can produce the surfactant of particular HLB value. That is essential for your formulation. So some examples are given. Surfactant and HLB values are given in the table. Polyethylene glycol 400 monostearate, it is having the HLB range of 11.6. Spans, you can see they are having the HLB value below 9. They are so why they are called as the lipophilic surfactant. And all the twins are having the HLB value above 9. You can see twin 20, twin 40, twin 65, and twin 85. They are all are the hydrophilic surfactant. Sodium oleate is also hydrophilic surfactant. The next moving toward the classification of surfactant. Surfactants are classified into 4 categories depending on the charge present or not present on their surface. Anionic surfactants are mostly soaps, sulfonates and sulfates. Anionic surfactants are having the negatively charge. Okay, anionic surfactants are having the negative charge. Then second category is the non-ionic surfactant. By mistake, the only one number is given to all the these surfactant. Actually, it should be 1, 2, 3, 4. Okay, this is by mistake. So anionic surfactant are having negatively charged. Non-ionic surfactant, as the name indicates, they do not have any type of charge like spans and twins. These are the examples of the non-ionic surfactants. Anionic surfactant most popular are the sodium lauryl sulfate. Anionic surfactant, this is the most popular anionic surfactant, sodium lauryl sulfate. Cationic surfactants are quaternary ammoniums. These are the cationic surfactants having the positive charge. And last are the amphoteric or deuterionic. Mostly these are the examples are betanes and amino acid derivatives. Amphoteric means depending on the situation, they may be act as an anionic surfactant or they may be also act as a cationic surfactant. Okay, they do not have their particular identity, and this is depending on the pH. Suppose the pH of the solvent is acidic or basic. Depending on that, they may be act as an anionic or cationic surfactant. But anionic surfactant, particularly, they are the negatively charged. Cationic surfactants are toxic in nature and they are very rarely used in the formulations. Okay, due to their toxic nature, they are having the antibacterial property. They can damage the cell of the microorganism and they are also act as a bactericidal. Apart from their surface active surfactant activity, they are also act as a antibacterial. Okay, so because of their this property, they can be sometimes preferred in particular types of creams to avoid the growth of the microorganism. Okay, some of the other types of new classes of surfactants are polymeric surfactants or surface active polymers. Okay, and silicone surfactants. So first of all, we will see the anionic surfactants. As I already told you, they are having contain the negative charge. Okay, they are indicated by the group carboxylates RCOO, negatively charged on their surface. Okay, so soaps. These are the lauric, stearic acid, palmitic acid, myristic acid. Okay, these are the nothing but the soaps. They are having the anionic charge and they are act as a surfactant. Most of the triglycerides, they are used for the formulation of the soaps. Okay, triglyceride source of this triglyceride is the tallow or lard. What is the tallow? Tallow is the beef fat or fat which is obtained from the beef, and lard is the one of the type of fat which is obtained from the pork. Okay, animal source is there. These triglycerides are from the animal origin. Beef से मिलता है tallow and lard from the pork skin. Okay, and monoglycerides used in industry is commonly vegetable origin. जो monoglycerides use होते हैं, they are mostly the vegetable oils are used for the formulation of the soap. Okay, you know that by combination of these oils and alkali, soaps are prepared. Okay, which type of alkali are used to prepare the soaps? Sodium hydroxide, potassium hydroxides are there. Okay, most popular, these alkalis are used to prepare the soaps or anionic surfactants. Okay, when the sodium hydroxide is used, it produces the solid soap, and when the potassium hydroxide is used as a alkali, it produces the liquid soap. Okay, so to produce the soap, which essential things are, you require the lipid or fat. It may be triglyceride or it may be monoglyceride, and the alkali is required. And so by combination of this triglyceride and alkali, you get the stearate. Suppose if you are using the triglyceride, you get the sodium stearate and glycerol is the byproduct. Okay, the sodium stearate is nothing but the soap. It is the soap. Okay, and these are the examples of monoglyceride: lauric acid, myristic acid, palmitic acid. So from this monoglyceride, you can prepare the soap, or from the triglyceride, that is from the animal origin, you can also prepare the soap. And this soap is act as a anionic surfactant. Okay, soap making oil chart is given here because the soap is used as a anionic surfactants. When the first column contains the different types of oils. Okay, that is the vegetable oils are also there, and some animal origin of fat are also included in the first column. Coconut oil, palm oil, olive oil. Okay, these are the vegetable origin. Lard, tallow, these are the animal origin. Palm kernel oil, shea butter oil, and castor oil. Again, these are the vegetable origin. Okay, and which type of hard or soft soap or brittle soap is prepared is depend on the which oil you are using or which type of fat you are using. Okay, and different properties of the soaps are given depending on the which oil you are using. When you are using the coconut oil, a large fluffy bubble, highly cleansing, high amount can be too drying, makes a white bar. Okay, so depending on the which type of raw material you are using, the different properties of soap you can prepare. Next category of anionic surfactants are the sulfates and sulfonates. Okay, so sodium lauryl sulfate is the sulfate category of anionic surfactant. Then sodium laureth sulfate is also there. It is used by the name Texapon, Ecosol, Imex. These are the brand name. And its structure of the sodium lauryl sulfate is also given on your screen. These anionic surfactants are less toxic as compared to the cationic surfactant, and it is mostly you can see in the toothpaste, in the shampoo, okay, in the different bars. This sulfate is very popularly used, sodium lauryl sulfate. Then sulfonate is the another category of anionic surfactant. It is a linear alkyl benzene sulfonates, sodium lauryl sulfosuccinates. Okay, so these are also useful anionic surfactants. Other anionic surfactants include organophosphor surfactants, for example, potassium lauryl phosphate, then sarcoside or acyl amino acids, sodium lauryl sarcosuccinate. Okay, these are the different types of other anionic surfactant. They are not as much as popular as that of the sodium lauryl sulfate, but they are also used in the different cosmetic depending on the need. Okay, the most used synthetic product is the lauryl sarcosinate. It is mostly used because it is having the bactericide property. Okay, and it blocks the blocking agent of hexokinase. Okay, that is the enzymes which is required for the growth of the bacteria. Okay, it means this is one of the anionic surfactant which acts like a cationic surfactant, because most of the time cationic surfactants are having this bactericidal property, but this is one of the anionic surfactant which is also having the bactericidal property. Next category in the surfactants are the non-ionic surfactants. Okay, they are more popular and more safe surfactants as they do not possess any charge, they do not interact with the cell surface, okay, and they do not show any toxic reactions with the human skin or cells, and so why they are more popular in nature. They are mostly used in the creams and emulsions. Okay, so first are the ethoxylated alcohols and alkyl phenols. That is the ethoxylated linear alcohols, ethoxylated alkyl phenols, cetyl alcohol, oleth 20, stearate 2, breach. Okay, it is popular by the name breach. It is a very popular surfactant. Okay, stearate 2. Then fatty acid esters are also there. Glyceryl monostearate, PEG 1000, sorry, PEG 100. That is polyethylene glycol. Okay, polyethylene glycol is the very commonly used surfactant, non-ionic surfactant. Then sorbiton esters are there. They are also popular. Span and twin. Okay, polyoxyethylene sorbiton ester. Okay, polyoxyethylene sorbiton monooleate, monolaureate. Okay, these are nothing but the span and twins. These are the most popular non-ionic surfactants, spans and twins. These are the brand name. As such, they are the sorbitan esters. Then nitrogenated non-ionic surfactants are also there. Tertiary amine oxides, ethoxylated imides are there. Natural non-ionic surfactants are the lanolin and cholesterol. Okay, you know that lanolin can be obtained from the fat, wool fat. Okay, it is also called as the wool fat. Lanolin, you know that you might have been used in the formulation in the first year. Okay, pharmaceutics के formulation आपने lanolin use करके किए होंगे. So it is also called as the wool fat because it is obtained from the wool of the sheep. Okay, then cholesterol, you know that it is a natural surfactant which is present in your body also. Okay, which is also essential for the formation of vitamin D in your body. Okay, then lecithin is also non-ionic surfactant. It is prepared from the soybean, so it is popularly called as the soya lecithin. Okay, soybean is not only the one of the source. There are other sources of lecithin also. So soya lecithin is most popular to prepare the liposomes. It is a non-ionic surfactant, mostly used for the formulation of the liposomes. Okay. So you know that we have seen the liposome in the last semester in the novel drug delivery system. What are the liposomes? Okay, so for the formulation of the liposome, particularly these lecithins are used as the non-ionic surfactants. So what are the advantages of these non-ionic surfactants? Non-ionic surfactants are less irritating because they do not interact with your cell, because they do not have any charge, so they are least irritating, compatible with all other type of surfactant. Okay, if you added anionic surfactant along with the non-ionic surfactant, then there is no interaction. If you added the cationic surfactant along with the non-ionic surfactant, then there is no any reaction. But you can't use anionic and cationic surfactant together. Okay, they neutralize the charge of each other. But non-ionic surfactants are compatible with all type of surfactant. Okay, it is also compatible with the salts. Okay, whether the positively or negatively charged salts are used along with this non-ionic surfactant, there is no any interaction occur. Compatible with the widest pH range. Okay, in various pH range you can use this non-ionic surfactant, but it is not happen with the anionic or cationic surfactant, and it is most versatile. Okay, they can be act as a wetting agent, they can be act as a emulsifying agent, okay, foaming agent. So they are very versatile use, and so in many cosmetics it can be used. Okay, so this is about the surfactant. What are the surfactants? What are their properties? We have seen up till now about the anionic surfactants and non-ionic surfactants. Okay, I think there is a time of your third lecture now. आपका third lecture है ना? Yes. Anybody?
No, sir, it has been cancelled.
सेल एयर मोलिकुलर बायोलॉजी का था ना?
सर कैंसिल हो गया वो, आज नहीं हो रहा.
Okay, okay. Thank you. Okay. So let's moving toward the cationic surfactants. So these are the also called as the quaternary compounds or quats. Okay, quaternary compounds or quats, and these are the toxic in nature. I have already told you that. So they kill the bacterial spore rather than inhibiting their growth. So they are the bactericidal, sporocidal. Okay, so they kill the microorganism. So they are toxic in nature, and how they act? They attach to the bacteria and causes the cytoplasmic membrane to leak. They break down their cytoplasmic membrane, and whatever the essential nutrients present inside the cell, they get outside. Okay, they come outside the cell, and there is a death of the bacterial cell. Okay, so in this way they act as a bactericidal, and due to this nature they also may damage the human cells. Okay, so they are considered as a toxic in nature, but sensitizers are generally more effective in the alkaline pH range. Okay, squat sanitizers are generally more effective in the alkaline pH range. They are mostly useful in alkaline pH range. Okay, then quats are inactivated by the anionic detergent. As I have already told you that anionic and cationic surfactants can't be used together. Non-ionic surfactants can be compatible with any other surfactant, but quats inactivated when it is used in combination with the anionic detergents, particularly soaps. Okay, by many non-ionic detergent and by calcium, magnesium, ferric, and aluminum ions. Okay, they are also not recommended in hard water. Okay, they are not recommended to be used in the hard water, and their effective levels are at 200 ppm. They are effective only above the level of 200 part per million. And Other type of cationic surfactants examples are cetyl pyridium chloride. Okay, apart from the quads, it is also popular cationic surfactant, cetyl pyridium chloride. It is also act as a bactericide and fungicide. Okay, and if you added the second hydrophilic group, okay, that is amide or ethylene oxide group is attached, it becomes bactericide. Okay, and is also compatible with the anionic formulas. Okay, if you added one more amide or ethylene oxide group to this, they can be compatible with the anionic surfactant also. Then next category of cationic surfactants are the nitrogenated surfactant with a second hydrophile. Okay, cationic surfactant can be used, cannot be mixed generally with the anionics. Okay, why? They react with one another to produce the insoluble cationic compound. Okay, which type of compound is produced? What is the name of that compound? Cationic. Okay, it is the combination of cationic and anionic. So this new terminology is used when cationic and anionic are mixed together. So the compound produced is called as a cationic. Okay, so it indicates the combination of both. Then another types of cationic are the alkanoamides. They are among the best foam boosters. Okay, and neutral and alkaline pH, they act as a foam boosters. Alkanol, alkanol amides. These are the cationic in nature. Then fatty acid alkanolamides are commonly used as a foaming and a wetting agent in hard dish washing detergent. They are also used in shampoos and bar soaps. Okay, particularly the diethanol lauryl cocoamide. Okay, cocoamide DEA, cocoamide MEA. These are used as a detergent and a foaming agent. So alkanol amides are mostly used as a foaming agent and they are the cationic surfactant. Last category are the amphoteric surfactant. As I already told you that depending on the situation, they may change the party. Okay, they may act as a anionic or they may act as a cationic. Okay, and it is mostly depend on the pH. Okay, the presence of pH depending on that they can decide their action, whether to become anionic or a cationic. So in most cases, it is the pH which determine which of the group would dominate, whether the anionic group will dominate or the cationic group will dominate. Okay. So amphoteric surfactant, particularly the amino acids, ones are quite biocompatible and are used in pharmaceuticals and cosmetics. Okay. Some examples of these amphoteric surfactants are the aminopropionic acid, imidopropionic acid. Okay, their properties are also given. There, when we are talking about the aminopropionic acid, their isoelectric point is around pH 4. They are soluble in acid or alkaline solution. They adsorb on the skin, hair, and textile fibers, and they are used as a antiseptic and lubricants for hair and fabrics. Okay. So due to their adsorbent property, they are used as the antistatic. Antistatic agent means they neutralize the static charges which is produced on the surface of the material. So they are called as antistatic and they are also act as a lubricant. Imidopropionic acids are also used as a textile softeners. Okay, means both are apart from the cosmetic industry, they are also popular in the textile industry. Third type of amphoteric surfactant is the quaternized compounds. Okay, quaternized compounds have the similar structure. The most important are the betanes and the sulfobetanes and or taurines. These are the examples of the quaternized compound. Betanes, sulfobetanes, and taurines. These are the popular quaternized amphoteric surfactant. Okay, these surfactants are amphoteric at the neutral and alkaline pH. and cationic at the acidic pH. Actually, they are anionic. Okay, at alkaline pH and neutral pH पे वो anionic रहते हैं and cationic at the acidic pH. They act as a cationic at the acidic pH. Okay, so this is also used in the soap bars. Okay, it is also act as a dispersing agent in most of the formulations. Okay, it is a different category of surfactant. Okay, commonly surfactants are classified into anionic, cationic, non-ionic, and amphoteric. But polymeric surfactants are somewhat different from these previously seen examples. These surfactants have many uses in a particular as a colloid and a nano emulsions. Okay, these are nothing but the polymers. Okay, however, these types of polymeric surfactants examples are CMC. You know that it is a popular polymer which is as a CMC, carboxymethyl cellulose. Then Aristoflex AVC, it is another type of polymeric surfactant, and hostasarin SAF. It is a mineral oil, isopropyl palmitate, triolaureate 4-phosphate, rapeseed oil, sorbitol ester, ammonium, acrolyl, dimethyl laurate, VP polymer. Okay, it is a combination of all these material. Okay, so it is a blended, we can say, surfactants. They can be used in particular types of creams and lotions. Okay, they can be also used along with the your conventional surfactant. Then another category, apart from the polymeric surfactant, silicone surfactants are there. They are having some particular advantages over other types of surfactants. Okay, they improve surface tension reduction, wetting in water and oil-based systems. Okay, they are having the emulsifying property, film forming property, and they do not cause the irritation and improve skin feel. Okay, the example of this silicone surfactant is dimethicone copolyol. You can see it is today it is a very popularly used in some of the cosmetics. Dimethicone copolyol. Okay, the silicone soluble portion is shown in red and the water soluble portion is shown in the blue. Okay, so that is the structure in which group is water soluble and which group is oil soluble or silicon soluble. It is indicated by the two color. Okay, so blue color, that is the hydrogen containing group, that is a definitely it is a water loving portion. Okay, or hydrophilic portion. So this is more about the dimethicone copolyol. It is also available in the different grades, or we can say in the different molecular weight. Okay, PEG dimethicone 800, 6353, and 12500 molecular weight. Okay, so depending on the your requirement, you can use the different molecular weight of dimethicone copolyol. Okay, just like polyethylene glycol, it is also surfactant. It is available in polyethylene glycol 400, okay, to polyethylene glycol 6000. In different grade, it is available. Okay, polyethylene glycol, the low molecular weight is available in the liquid form, and the same polymer, when the molecular weight increases, it is available in the solid form. Polyethylene glycol 6000 is available in the solid form, and PEG 400 is available in the liquid form. Okay, so it is depend on the its molecular weight, and depending on its molecular weight, its function also changes. Okay, some 4000 is 400 is used as a PEG 400 is used as a plasticizing agent. Okay, and PEG 6000 is used as a solubilizing agent, or it is used in the solid dispersion formulation. So depending on the molecular weight and your requirement, you have to select that grade particularly. Okay, the PEG 8PG coco glucoside dimethicone, it is another derivative of the dimethicone. Okay, it is a silicon surfactant. It is mostly used in the skincare product like creams, lotions, tonic, and shower gels. It is also used in shampoos, conditioner, hair tonics, hair creams. Also used in the sunscreen products. Also used in the lipsticks and healthcare. So it is versatile. Okay, PEG8, PG coco glucoside dimethicone. It is a versatile surfactant. Okay, it is somewhat having the more application than conventional surfactant. Okay, it is a versatile surfactant. So it is these surfactants are become more popular as compared to your conventional surfactant today. Okay, so this is about the one of the important component of the cosmetic, that is the surfactant, which is mentioned in your syllabus. Okay, without the surfactant you don't think to formulate the any kind of cosmetic. Okay, in every cosmetic, if you see, these surfactants are added. Okay, might be their function may be different. Sometimes it may be act as a emulsifying agent, sometimes it may be act as a detergent or wetting agent or solubilizing agent. Okay, but it is essential for the formulation of the cosmetics. Okay, so here today's topic is over. Okay, and then see you in the next lecture. Now you can leave the meet. If you have any question, you may ask. Otherwise, you can leave the meet.